In this video, we're going to be looking at the two ways that plywood is attached to the top plates in the various seismic retrofit guidelines. We're going to be looking at the history behind these differences, and we're going to take a look and see which one of the two is the best way to do it. So this first way to do it, we see here in Standard Plan A. You see how here at the nails, we have the nails up here at the top, and we also have nails here down at the bottom. Now this is all the way along the plywood. You see the nailing of the upper top plate and the lower top plate all along here. Now we see this in a few different guidelines, and we're going to look at every one of those in the rest of this video. So if you come over here, this is from this is another way to do it. This is from chapter A3 of the International Existing Building Code, and you see right here there's the nails in the upper top plate only. Right here, this section right here, that is the lower top plate at the bottom, and this is the upper top plate. So you see there's absolutely no nails right here in the lower top plate. So we're going to look at both ways of doing it and see which one is the best. Right now we're going to look at every single building code and seismic retrofit guideline until December of 2020, which is right now. So everything that was published before now, we're going to be looking at this particular connection, the plywood to top plate connection. This is the first instance I'm aware of where there was a construction detail that showed nailing of plywood in an official document. This comes from the guidelines for the seismic retrofit of existing buildings, published, I believe, by the Structural Engineers Association of Southern California in the early 90s, quite some time ago. I was given a copy when I went there for a seminar in the mid-90s. So what they had, the main thing here is we see that the 8 penny nails, 4 inches on center on the edges of each individual piece. So that means each piece of plywood will be nailed like this. And the really critical thing here that is important to know is this edge nailing right here. You see how these little dots right here, there's a dot here, a dot here, a dot here. All those little dots, that all represents edge nailing onto the plywood. So here's that's the edge of the plywood, just like it says right here, all edges of each individual piece of plywood. Now there's two top plates here. There's the upper top plate right here, and then there's a lower top plate right here, and all the nails go into the upper top plate. This is from the 2015 Special Design Provisions for Wind and Seismic, and this is an American Wood Council publication, and it is a part of the building code for the entire country. So anything that applies here applies to all new construction. So this is the basis of new construction in the building code. And let me show you what it tells us here. So here we have the nailing along all the edges, just like we saw a little while ago. Here at the bottom, we also see the nailing at the bottom. It's spaced, 6 inches apart, 4 inches apart, whatever. Main thing is it's here at the bottom. And then when you come over here, you have nailing again at the upper top plate. Remember, this is the lower top plate. This is the upper top plate. Now, if you want to stagger the nails, that's fine too. So you can go into the upper top plate. Here's a nail here, here's a nail here, here's a nail here. And those can be spaced, whatever, let's say just 4 inches on center. But you can't put it here. So you can't come here and put one in, 4 inches over here and put one in, 4 inches up here and put one in, 4 inches come here. And that's what we're going to be looking at. That is the way Standard Plan A and some other guidelines do it, and it is in contradiction to what is in the special design provisions for wind and seismic. So historically, this is the next retrofit guideline that came into existence in Los Angeles. And again, you can see it has 8D common nails at 4 inches on center at sheathing edges. OC stands for on center or apart. And sheathing is the same thing as plywood. So again, this was intended to resist 380 pounds of earthquake force for each linear foot of plywood, just like we saw previously. This is from the City of Seattle retrofit guideline. And you can see here we have the exact same thing. We have the edge nailing along the upper top plate here and the upper top plate here. Even though it doesn't, I don't show that here, the nailing pattern here again is at 8D commons at 4 inches on center, just like the other guidelines. So this actually took the information from the original precedent of the California Existing Building Code guidelines for retrofit existing buildings and made a new drawing, which I think is much better. It's much clearer because it shows the upper and the lower top plate and the way it was nailed. It also shows the shear transfer ties. And the shear transfer ties, notice the shear transfer ties, the nails that go into the shear transfer ties in this direction down that way into the upper top plate, they only go into the upper top plate, which is why these nails here are only going into the upper top plate as well. So this framing anchor, also called a shear transfer tie, is connected to the upper top plate, and the plywood is also connected to the upper top plate. And we're going to see the reason for that when we actually take a look at the standard Plan A detail. Many people may not be aware of this, but the hardware manufacturer Simpson Strong-Tie also has a plan set, and it is just like all the other ones. As you can see, we have 8D common nails at 4 inches on center on all edges of each individual piece of plywood, and all the nailing is on the upper top plate. Again, this is to resist 180 pounds of earthquake force for each linear foot of plywood. This is from the City of Portland retrofit guidelines, and this construction detail is not very clear, and it was actually lifted from the Los Angeles retrofit guidelines, but it shows the exact same things. We have 8D common nails at 4 inches on center at the sheathing edges, and so this again is a plywood pattern, nailing pattern that is supposed to resist 380 pounds of earthquake force for each linear foot of plywood. So this is from FEMA P1100. That's the most recent retrofit guidelines from 2019. And then you can see that the nailing is only in the upper top plate. So this plywood nailing is just like it was for the guidelines for seismic retrofit of existing buildings that was published in the 70s or so. So we've gone back about 50 years to the way it originally came out and the way Jim Russell actually originally intended these plywood nailing to be. So you can see it very clear here. It says provide all required nailing at upper top plate, and you see the nails right across here along the upper top plate very clearly. There are a few nails here at the bottom. There's one here at this lower top plate, one here, one here. It certainly won't hurt, but they're not required. So anyway, what you see here is what Jim Russell originally intended for standard Plan A. So as you probably noticed, all the retrofit guidelines ultimately referred back to Jim Russell's original work in the guidelines for the seismic retrofit of existing buildings as far as the plywood nailing goes. They all recommend 15/32 plywood. They recommend 8D nails. They recommend 4 inches on center on the nailing, and they recommend nailing into the upper top plate only. And the shear walls can resist 380 pounds per linear foot. Standard Plan A decided to change all of that, and let me show you how. You see here where it says 4-inch staggered spacing typical. That means you go here, 4 inches later you go here into the upper top plate, 4 inches later you go into the lower top plate, 4 inches over you go into the upper top plate, etc. So what you end up with is you end up with the edge nailing as being 8 inches. So we have 8 inches here to here, 8 inches here to here, 8 inches here to here. And when you only have 8-inch edge nailing, the capacity of the shear wall drops down to 190 pounds per linear foot. So remember earlier we saw that the plywood is all nailed at 380 pounds if you put them 4 inches on center on the edges. Well, in this case, they're only 190 pounds, which is a whole lot weaker. Let me show you exactly why that's a problem. Now, as I said, Jim got really sick. He wasn't able to see this to the end, and I'm sure he would not have approved this if he had seen it, but that's what we ended up with. Let me show you why it's such a problem. So this is, again, our upper top plate, and then this is our lower top plate, and you see how these are 4 inches apart along each plate. So here we have one, and then we have one right here, that's 4 inches, and we have one here, that's 4 inches, 4 inches, 4 inches. So in effect, along the entire upper top plate, you have a nail that's every 8 inches. Now the building code does not even have a table that recognizes shear walls that are nailed on the edges at every 8 inches. But anyway, that's what we got. So the way it would actually work is this is a floor joist, And a floor joist is a part of the floor. It supports the floor you walk on. And what happens is when this slides this way, we want to keep that from sliding. So what we do is we take this piece of metal right here, it's called a shear transfer tie, and we nail it to the joist right here, and then we nail it down here into the upper top plate. Now the upper top plate is only 2 inches thick, or 1.5 inches, usually 2 inches. The nails that come in here are 1.5 inches. So all the nails go into this upper top plate. So what that means is earthquake force comes this way, pushes on the shear transfer tie, that goes into the nails that again are only 1.5 inches. So that force goes into the upper top plate, it pushes it that way. Then that force goes into the nails that are also in the upper top plate. And then eventually, when this piece of plywood pushes on the top like that, the bottom of it also pushes that way into the bolts. So these nails here on the lower top plate, they're not connected to the shear transfer tie. Therefore, they are not doing anything. So anyway, that is the problem with standard plan A. Here's a good comparison for the two types of nailing. On the left, you see what you would find if you use the special design provisions for wind and seismic and the guidelines for seismic retrofit of existing buildings and so many other guidelines that we looked at. On the right, you'll see standard plan A and 2 other guidelines that are mixed up with that. Let's see what happens when we apply these nailing patterns to a standard plan A retrofit. This table right here is from standard plan A, and it tells us that if a house is 1,200 square feet, it's heavy construction, it needs 20 linear feet of plywood on each side. Now if it's nailed 4 inches apart on edges with 10 penny nails as intended, we need 20 linear feet of plywood. Now that is 4 inches on center on the upper top plate, as Jim Russell intended, as the special design provisions of wind and seismic recommends it's done, City of Los Angeles, all those different guidelines that we looked at. If those are used, so we have 4-inch nailing on the upper top plate, we need 20 linear feet on each side because standard plan A was designed around a 380 pound per linear foot plywood nailing. On the other hand, if we use standard plan A system, where it's nailed inches apart with 8 penny nails as required by standard plan A, we need 40 linear feet on each side. So just as we saw, 8 penny nailing, 8 inches apart on the upper top plate alone only provides 190 pounds of earthquake resistance per linear foot, and therefore we need twice as much. So we need 40 linear feet on each side, which gets pretty expensive. Here we see 2 identical floor plans for 1,200 square foot houses that are considered heavy according to standard plan A. Now the one on the left will be nailing in the upper top plate only, as we saw in all the guidelines that we just looked at. And then on the right, we'll be nailing in the upper and lower top plates, just like we saw in standard plan A. Now this is what happens when we do that. When we have the 380 pounds per linear foot nailing, we only need 20 linear feet of plywood on each side. So we had 20 feet here, 20 feet here, 20 feet here, and 20 feet here. So just 20 feet on each side for a total of 80 linear feet. Now if we nail into the upper and lower top plates, then we need 40 linear feet, because remember, when we do that, the plywood can only resist 190 pounds per linear foot. So here we need 40 feet, here we need 40 feet, here we need 40 feet, here we need 40 feet. And as you can see, in order to meet the requirements that standard plan A has defined for us, we'll need to add, approximately 20 linear feet of extra foundation over here. So clearly this system does not work. So the other guideline where we find the double top plate nailing is in FEMA DR-4193. And as you can see here at the upper top plate, we have a nail every 8 inches. In the lower top plate, we have the exact same thing. So overall, the edge nailing is every 8 inches on this piece of plywood right here. The real reason why this was even considered is because of Standard Plan A. Standard Plan A was a precedent. It's kind of like case law. Standard Plan A had been, in their mind, had already been hashed out. A bunch of people had been, talked about it a whole bunch, and they finally figured out that this double top plate nailing was a good idea, and that's why it's allowed here in FEMA 4193. It says that this effort would not have been possible without prior development of the following documents: Standard Plan A, Residential Seismic Strengthening Plan. So that is why we find this in FEMA 4193. It wouldn't be there otherwise. So then the real question is, well, where did it come in Standard Plan A? And what you see, continually is that a certain standard will influence the development of another standard, which is what it should do. And in this case, Standard Plan A was influenced by another document, but it was not a code document. It was not even a government document, and we'll see what that is. So this is the final case where I could find nailing in the upper and the lower top plates. This comes from the Simpson Strong Tie catalog. This detail was in their publication from 2007 that was for homeowners for the retrofitting of their homes. So this must have been used by the people who are putting Standard Plan A together, because there's no other way that they could have come up with this. There's just nowhere, you don't find it anywhere. There's no code references. There's not in the California Existing Building Code, not in the Los Angeles Building Code. There's no precedent for it. So the only explanation I have is that. And the interesting thing is, I do recall at one of the meetings where the building official from San Leandro had talked about how he had hired someone who worked for Simpson Strong Tie, making their drawings like this for them. So either that particular person had already drawn a detail like this, or he was fully aware of it and would have also had a tendency to draw the detail like this. So that's why this detail is in Standard Plan A, and it's the only time you ever find it. And actually, it's a little bit on the crazy side, because if you think about it, this was not put in because of any engineering expertise. When you get down to P1100, where there is some true engineering expertise, as well as what Jim Russell's original design back in the guidelines for retrofit of existing buildings and the California Existing Building Code, those are all rational. But this one, it just came about because of some quirk, some human error. And this is just to show that even though it looks like scientists with white coats and microscopes and things, or they're writing codes and things like that, it's just human beings. And sometimes things like this just happen. When I was doing research on another topic, I came across a publication by the Consortium of Universities in Research in Earthquake Education, publication W-13. And in it, I found some details that show this double top plate nailing, and I'm going to show that to you right now. So this is the really critical thing about these details. It says 8D gun nails, 2 rows, 4 inches on center. So this is actually different than what Jim Russell had. He had 4 inches on center on the top plate only. So this would have worked because it has 4 inches on center on the top plate. The ones at the bottom top plate, well, they don't hurt anything. So let's look and see exactly how they did that. So here you see the upper top plate nailing along here. Then you see the lower top plate nailing along here. And then interestingly, they went ahead and put double rows of nails on each side. So you have a double row of nails right here, and you have a double row of nails right here. So that's what the problem is. Whoever did Standard Plan A, what they did is they took the information right here, which had a double row of nails, and then rather having each row 4 inches on center, they put each row 4 inches on center, they staggered them. So there would be, one nail 4 inches down on the lower top plate, one nail, then 4 inches up on the upper top plate. So the nails ended up being 8 inches on center on the upper top plate. And so this is how this influenced Standard Plan A and where the problem came from. It was just a misunderstanding and a misinterpretation of the Curry information in this research project. Right now, I'd like to look at the history of these two nailing patterns. So the first guideline was the guideline for seismic retrofit of existing buildings right here. And then that turned into the 1997 Uniform Code for Building Conservation. And then that reincarnated the California Existing Building Code, and it's still in there in the form of Appendix Chapter A3. And then the special design provisions for wind and seismic, well, that I'm not sure when that came out, but I do have a 2008 copy of special design provisions, and it is in there. So I know it goes back all the way to 2008, and that has the single top plate nailing. And then the City of Los Angeles has the same thing, City of Seattle, City of Portland, Simpson-Strong type plan set. Now, it's interesting, the Simpson-Strong type plan set actually has a single top plate nailing, but when you go into their other guideline, the Simpson-Strong type seismic retrofit guide for raised foundations, and the one I found was from 2007, that one has double top plate nailing. So Simpson has, a little bit confused there. They have single top plate nailing, and they also have double top plate nailing. And anyway, then finally we have the SEMA top plate, the single top plate nailing in FEMA P1100, except there's a few nails in the bottom top plate, and I could not find an explanation for that. So when we go to the double top plate nailing, that starts out with Curry WS13 in 2002. Standard Plan A came out approximately 2003. So you can see the influence that WS13 had on 2003. The only problem is that when Standard Plan A made their detail, 8 inches on center in the top plate and 8 inches on center on the bottom plate, in fact, gave us an 8 inches on center on the upper top plate. Whereas the Curry test, it had 4 inches on center on the top, 4 inches on center on the bottom, so it would have performed exactly as it should have with 380 pounds per linear foot. So then that found its way in the Simpson-Strong type seismic retrofit guide for raised foundations. I'm assuming that this was published in 2007, that they got their details from the 2003. And then this FEMA DR 4193, that came out in 2015, and it explicitly states that Standard Plan A influenced it. So I'm sure that's where they got the double top plate nailing. So anyway, that's the history of the whole thing. It has had some pretty serious implications because Standard Plan A has been used on thousands and thousands and thousands of homes. And hopefully someone can do something about Standard Plan A and modify that detail.